I'm Anil Kumar, and in this video I'm going to discuss with you how to solve absolute function inequalities. We have three different methods of solving inequalities. One of them is the graphical method, the other one is for absolute functions and or method, and then a piecewise function approach. Now we have already discussed graph in another video. This time we'll discuss and or method. Now what does it really mean? Things will be absolutely clear to you. Let us understand the concept. So the concept here is, what is absolute function? When I say absolute value of x plus 2, then what are we looking at? Let's say this is a number line, and let's put some numbers here. 1, 2, 3, 4, 5, 6. These are negative side, and then 1, 2, 3, 4, 5, 6 on the positive side. Now when I say x plus 2 absolute value, that means the vertex of this is 2 units to the left, so the function actually has a point here. So that is the midpoint at minus 2. Right? That is the midpoint, x plus 2. Now the inequality is, or can be written as, two parts. That is to say, we are saying this absolute value of x plus 2 is less than 3. Now when absolute value of x plus 2 is less than 3, it really means that x plus 2 is less than 3, but it is greater than minus 3. Do you get the idea? Now we can solve it very easily by saying x is, take away 2 from all the sides, so we get 1 here, minus 5. Correct? So the right side of this inequality can be seen as x between minus 5 to 1, right? So when we are saying that this absolute function is within 3, that means 1, 2, 3, so that is bringing you to 1, and 3 units away, 1, 2, 3, right? So that is minus 5. Do you see that? So this part on the right side says that x could be between these 2 points. So I may just circle this just to show you. So this is the right portion. Is it okay? Now let us see what the left side is saying. Let's understand. From the very basic definition, it is saying that the absolute function of x plus 2 is greater than 1. It really means that x plus 2 is less than minus 1, it's like away, right? Or x plus 2 is greater than 1. So that is what it is saying, correct? So let me draw a line in between and then we will solve it. So that means x is greater than, if you take 2 on this side, it becomes minus 2, so you get minus 1. And in this case, if you take 2 on this side, minus 2 means minus 3. So this really means that for the left side, when we say absolute function is greater than 1, that means from here, anything beyond this point, do you see that? Anything beyond this, 1 unit away at least, do you see that? That is what it's saying. So we say this is minus 3 and that one is minus 1. You can get it from logic also, correct? So when the absolute function is greater than, it is always or, like this side or that side, that much away. When it is less than, it is kind of in between. Now when you have double inequality, then we have to find common solution, right? So now what is the common solution? Which satisfies both the things. So from the diagram you can see this orange represents less than 3 and this portion in pink represents greater than 1. Now the common portion clearly is from here to there. Is it okay? And on this side it is from 1 to minus 1. So that is the common solution, right? So we get our answer as common solution minus 5 to minus 3 and -1 to +1. So this is the method. So what you really do is redefine the absolute function, break the double inequality into two, right? So we broke it down to two, right? So we had right side inequality and the left side inequality. Find solutions for both of them, and then the common solution gives us the real solution of the double inequality. I hope that helps you to understand the process. Now, in the next video, we'll talk about piecewise approach. So here also we kind of broke down this into plus and minus pieces, but we'll look into this in the next video in further details. I hope this method is clear to you. Thank you and all the best.